Welcome to another tutorial on MATLAB. In this particular tutorial series, we are looking into the concept related to Simulink. In the previous tutorial, we have seen how to create a basic add logic in Simulink. In this particular tutorial, we will be looking into how we can enhance this model to create a different behavior, and also we will be covering two major concepts in this particular tutorial, which is mostly being asked in interview as questions when related to MATLAB Simulink modeling. So let's get started. So as we have created a basic adder logic, so now we will be creating a counter which will be increasing up to certain number. So basically this is being asked in interview as a question, which is how we can implement it. So basically we will be adding like we will be connecting our output, which is the output of the add block, and then we will be summing it up in the sum block. So basically what will happen over here, we will be increasing the signal, the output signal every sample time by the count of 1. After some time, we will be resetting that count back to 0. So here we will also cover the concept of algebraic loop. Suppose if you do simulate the model now, so you can see we are facing some issue which is called Simulink cannot solve algebraic loop. Algebraic loops are the major issues in the model when we try to connect the output directly to the input, like this feedback which you are able to see, that is directly getting connected to the input, and that is creating the issue. And one solution to this algebraic loop is adding a unit delay block. So basically what it will do, it will give some initial value to the signal which is getting connected back to the input from the output. It will try to solve the problem that is related to the algebraic loop. Basically now here we are connecting the scope. Coming to the algebraic loop, so what is basically an algebraic loop? So previously if you ignore this particular block was not there, and we were connecting the output from here to here directly. And when we tried to simulate this model, then we were needing like two inputs to do this add operation. What is the first one is this one, and the second one is this one. But when we try to add these, so the signal B that is dependent on the output, and here we are creating a deadlock. Like if the output itself is not available, how you can add it inside the add block? Because the calculation for this one, like if you consider the signal as C, is not yet completed, and you are expecting this to be present as an input for this add signal. So this is creating a conflict in the model, and this type of conflict when you deal with model creation is called an algebraic loop. To solve this issue, we have connected this delay block, which will initially have a value of 0. So basically it will pass 0 at the first sample time, and it will be added, and it will give the first output as 1. Then this 1 will be propagated here, then here it will be 1, and the overall output now will be 2. So this way the entire simulation will work, and that is how we are solving this issue with the help of a delay block. So this is the most common approach that is being used while avoiding the algebraic loop. So now let's look into the same. Now let's see the output that we are getting from this particular model, and this will generate a staircase signal. So basically what will happen over here is the value will gradually increase over time, and you will be able to see the output in the in the scope. So if you step here now, if you click on the individual signals that you are able to see now, you will have 0 and then again 1, then 2. So gradually you will be able to see what is the previous signal and what is the current signal that is getting added, and you are getting this output. So if you see over here, we are using two type of output blocks. One is the scope and one is the display block. So basically, if you want to see the entire response over time, then in that case, you will be needing the scope block, and the scope block will tell you at what time instant what is the value for that particular signal it is connected to. But in case of display, it will show you the current value only. So whenever the value is changing over time, like here the output signal is getting changed over time, and because of that you will be not able to see every value at every time's instant at one go using a display block. So we have connected a scope block which will record the entire value for that signal over different sample time, and later on if you just double click on the scope block, then you will be able to see what are the outcome or what is the output at every time stamp. And that if you see, it will generate a staircase type of signal. So now you double click on the, now if you see, if you double click on the scope block, then you will get this window, and here you will have some options. So let's go through the options. So the first is the configuration setting for the plotter wizard. So basically this is a kind of plot and which you will be able to see. From here also you can do the simulation, and here also you can stop the simulation. You can use the zoom button. Either you can zoom out or zoom in. You can also use auto scale. So basically if you click on the auto scale, it will fit the entire plot into a proper view so that you can view the entire signal. And there are also some tabs related to view, tools, simulation and help. So these we will be exploring over this entire series, how these things works, and we will see in detail. So now let's auto scale the plot. So before that, we have selected the setting open at start of the simulation. Now if we close the simulation and start it again, then you will be able to see the plot is getting generated, and it came out automatically because of that checkbox. And this is how you can generate a staircase type of system. And previously we were adding only one, now we are adding two. So every sample time it is adding 2 as the number. So this is how you can generate a staircase type of signal from your Simulink model, and this is how you can do the simulation for generating a staircase type of signal. So the main concept over here what we covered is how to generate a staircase type of signal. And along with that, we also seen what is an algebraic loop, and what is the problem that an algebraic loop creates while we do the simulation, how to solve that algebraic loop. This is one approach to solve the algebraic loop. There are multiple approaches that are there to solve the algebraic loop, which we will be also discussing later on in this particular tutorial series. You will have a better understanding about the algebraic loop. You can also give a satisfactory answer when you attend for any interview. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. This will help us to improve your experience of learning MATLAB in this channel. Have a great day here. Thank you and happy learning MATLAB.